Good morning, all of you. This is Ram Mohan, working as head of department in electronics, presently at Government Polytechnic, Mahabubnagar. I am handling this subject, basic electrical and electronics. The subject code is 18EC105C. Now we are looking into the topic of resistors. Previously we have seen what a resistor is. Now let us see the classification of resistors. The objectives. On the completion of this class, you would be able to know the factors affecting the resistance of a material, the classification of resistors. Let us recap what we learned in the previous lesson. What is resistance? Resistance is a property of a material to oppose the flow of current. What is the unit of resistance? Ohm. That is a unit used to measure the resistance value. Now let us see the factors affecting the resistance of a material. The factors affecting the resistance of a material are: number one, the length of the element, that is our resistor element, preferably a wire. Then the area of cross section of that wire. Then the nature of the material, we mean the type of material. Then the temperature at which it is being operated. The resistance R of a material is directly proportional to its length, that is L, and inversely proportional to its area of cross section, that is A. That means resistance is in an expression we represent it like this: R is proportional to L, length of the wire, then inversely proportional to A, area of cross section. So if you equate it, we'll use a constant, that is rho, and the rho is proportionality constant, and it is called the resistivity of the material, or it is also called as the specific resistance. The unit for this resistivity is ohms per meter length, where L is the length of the material in meters and A is the area of cross section in square meters. Now let us see the classification of the resistors. Resistors are broadly classified as: number, fixed resistors, that means the resistance of the particular element is fixed throughout. Then variable resistors. Here the resistance value of the resistor can be varied. You can change it as per your requirement when it is connected into the circuit. Then there are further classified as shown in the next figure. Resistors are broadly classified into fixed and variable. Under variable, you have for general purpose and precision type. The precision type are preferred in instrumentation. In general purpose, they are further classified into rheostats and potentiometers. The potentiometers are again of two types. They are carbon and wire wound. Carbon type are generally used for consumer applications, whereas the wire wound are used for scientific and accurate applications, preferably in instrumentation and industrial purposes. Coming back to fixed, we have further classifications as carbon type, then precision type, and wide bond. In carbon, they are further classified into carbon composition, which is of solid type. Then you have a carbon film type. That means you will take a non-conductive cylindrical tube, then you will coat it with a carbon film. In the precision type, we have wide wound and metal films. The other one is wide wound. So that is based on the type of material or the manufacturing process. This is all about the classification of the resistors. So the fixed value resistor will look like that figure, brown one. Then the variable looks like a pot type, wherein you have a shaft which will be rotatable. Thereby you will be varying the value of the resistance. Now to consolidate, we have seen the resistors as a two-terminal passive device. Bilateral we call, because you can use with the leads or the terminals interchangeable. Then the resistance value of a material depends on its physical dimensions, and the resistors are basically of two types: fixed value resistors and variable resistors.